So we all know that this is a parent graph, y equals x squared. We all know that the a value is what? What's the a value on this guy? Positive 1, right? There is no number in front of the x squared, so it's positive 1 right there. Remember, the a value is the number that's out in front, the leading coefficient of the whole fraction, or the whole equation, I'm sorry. So the a value is out in front, which is 1. If you had parentheses around this x, then you would be able to look at your h value. If you had a number that's being added or subtracted at the very end, then you'd have a k value. So if you looked at it in vertex form, you'd be able to say what your vertex is by just looking at h and k, and of course thinking opposite on h. Now on any parabola with the a value of 1, you could use the pattern 1, 1, 2, 4, 3, 9 from the vertex. So if you did look at this parabola and you either found the vertex using the old method x equals negative b over 2a, or using the new method, the vertex form, and recognizing that your h is 0 and your k is 0, you'll see that your vertex is the coordinate 0, 0. Okay? So if we were to graph 0, 0, that would be the dot right there, dead center. Wow, that's ugly, I apologize. Of course, there's the axis of symmetry that runs right through it. So let me try to do that without making it ugly. And if we go with the pattern 1, 1, 2, 4, 3, 9, let me zoom in a bit. So from the vertex, if you go 1 over 1 up, that's 1, 1, so put a dot right there. And then if you go 2 over, so from the origin 1, 2, 4 up, 1, 2, 3, 4, put a dot right there. And last but not least, if you were to go over 1, 2, 3, 9 up, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's off of that screen. Let me just go up to 9 right there and put a dot up there. And of course we could take those coordinates and just simply map them over to the other side. What do I mean by map them over? This dot right here, it's 1 unit away, so go 1 unit this way. Put the dot right there. And then the other one's 2 units away, and the other one's 3 units away. And you have your perfect U-shaped curve with the a value of 1. Okay, so we know that any parabola with the a value of 1 is going to be this exact U-shaped curve. Okay, it's not going to be wider, it's not going to be narrower, it's going to be the same exact U-shaped curve. The only difference is if the a value is negative, it'll be the same U-shaped curve but reflected over the x-axis, opening down. Or if you had an h and k shift, it would be the same exact U-shaped curve but maybe shifted over here to the right, or maybe shifted to the left, or maybe shifted to the left and down. It's going to be the same U-shaped curve, just shifted if it had an h and k. So we are able to always use the pattern 1, 1, 2, 4, 3, 9, and that's only when your a value is 1 or negative 1. Okay? Now what if your a value was 2, like over here? Okay? So the a value is 2 right here. That means we cannot use the pattern 1, 1, 2, 4, 3, 9. Because we all know that if the a value becomes 2, the parabola gets vertically stretched. It gets narrower, right? It doesn't get wider. So it actually changes if your a value is not 1. It gets narrower. So how does this actually change our pattern? Well, think about it. If you were to What is this 2? What is this 2 doing to the x squared? What does it say right here? 2 blank x squared. What does it say? What's the operation between the 2 and the x squared? Anybody? Multiplication. You're multiplying, right? So technically, we are multiplying the parabola by 2. So technically, we're multiplying the outputs by 2. Now the pattern came from the original parent graph input-output. So if you do have an a value of 2, with the a value of 2, what happens is your outputs get modified by multiplying your outputs by 2 on the pattern. So remember I said you couldn't use the pattern if your a value was 2 or 3. If it was different than 1, you can't use it. You technically can use it, but you need to modify the pattern. So how are we going to modify the pattern? By multiplying the outputs by 2. Okay? So instead of 1, 1, I'm going to have 1, 2. This is my pattern. Instead of 2, 4, it's going to be 2, 8. Instead of 3, 9, it's going to be 3, 18. And obviously, 3, 18 is off the graph. So once again, I'm going to modify the 1 by multiplying it by 2, and I get 2 over here as an output. I modify the 4 by multiplying it by 2, and I get the 8 as the output instead of 4. So my new pattern for the A value of 2 is not 1, 1, 2, 4, 3, 9, but it's 1, 2, 2, 8, 3, 18, and I'm not even going to use 3, 18 because 3, 18 is off the graph. Does that make sense? Okay, so let's use this new pattern right here to graph this parabola. Now, once again, if I were to look at this parabola in vertex form, what would my h value be and what would my k value be so I could just clearly state the vertex? What is the vertex of number 2 if there is no parentheses around the x and there is no number being added or subtracted at the very end? 0, 0, right? So the vertex is 0, 0, just like the parent graph that we did on the left. So let's go and graph. Actually, let me make this graph a little bit nicer. Check it out. So I think that makes it a little better. Let's go to the vertex 0, 0. We're going to put a dot right at the, right at the center, 0, 0. So from that point, instead of 1, 1, 2, 4, 3, 9, because the A value is 2, we had to modify the second number. We had to modify the 1, the 4, and the 9 by multiplying them by 2. So it's really the new pattern 1, 2, and then 2, 8, and then 3, 18. No longer 1, 1, 2, 4, 3, 9. It's now 1, 2, 2, 8, 3, 18. So from the vertex, we need to go 1, 2. Does this open up or down based on the A value? It opens up. So let me go 1, 2. From the vertex, go 1 over and 2 up and put a dot right there. And my next one is not 2, 4 anymore. It's 2, 8. So let me go from the vertex 2 over, 8 up right there and put a dot right there, okay? So using that, I'm not even going to do 3, 18 because 3, 1, 2, 3, 18's way off the graph, so I'm not even going to bother with that. But I am going to reflect them over to the other side. So here's my reflection. It's 1 unit away, so go 1 unit this way and put a dot right there. And also, let's go to this one that's 2 units away and go 2 units this way and put a dot right here. And that's perfect enough to make a parabola. So let me just draw my parabola right through it. So as you can see, the parabola is a little bit narrower because my A value became 2 instead of 1. So 1 is like a regular U-shaped curve. 2 is a little narrower. 3 would be narrower. If you had a 10 right here, that thing would be really super narrow, really close to the y-axis, really super narrow. If you had like 50 or 20, that would look like a parabola. It would look like a thick line just running up and down. It would be so close together that it would look like a thick line. So I hope you guys understand how the A value affects it. So we could use a pattern 1, 1, 2, 4, 3, 9 from the vertex. However, we just have to modify it if the A value is not 1. So with that said, let's move on to number 3 right here. So looking at number 3, what is our HK value, guys? What is our vertex? Looking at number 3, our vertex is the HK value, but remember, think opposite on H. So what's our vertex? -2, comma, -1. Ladies and gentlemen, that's your vertex, the most important point on the graph. So let's go to the coordinate -2, -1. Let me zoom in here so we can do that. -2 on the X, -1 on the Y. That would be right here. So that's our vertex. Let's draw an axis of symmetry right through it. So there's my axis of symmetry. And one option is to use an XY table. We could always go back and use an XY table, but think about that. if you did plug in 0, you'd have to plug in 0 plus 2, get an answer, square it, multiply it by 2, subtract 1. You'd have to do all that math to get an output. And then you have to plug in another, and then plug in another, right? So that's a lot of work. You might want to use the pattern. Now, the pattern that we know for a value of 1, if a value equals 1, you could use a pattern 1, 1, 2, 4, 3, 9. However, this equation does not have the a value of 1. It has the a value of 2, right? So if your a value is 2, you need to modify your second numbers on your pattern. The 1, 2, 3 stay the same because those are inputs. So for the a value of 2, what's your new pattern going to be? It's going to be 1 what? 1, 2, right? What's the second pair of numbers? 2 what? 2, 8. You guys understanding this or no? Yeah? Okay, and the next one will be 3, 18. Now, if you're wondering, where am I getting these blue numbers, these second numbers? I'm simply taking the original pattern and multiplying the 1 times 2. So times 2 right there. Times 2, times 2. That's how I got 1 times 2 gave me 2. The 4 times 2 gave me 8. And the 9 times 2 gave me 18. So instead of 1, 1, it's 1, 2, my new pattern. Instead of 2, 4, it's 2, 8, my new pattern. Instead of 3, 9, it's 3, 18, which, by the way, you're probably not going to use. So now that we know the pattern, 1, 2, 2, 8, 3, 18, which we're probably not even going to use, the a value is 2, so we're going to be using this pattern instead of the a value 1 pattern, which was 1, 1, 2, 4, 3, 9. Okay, so we're modifying the a pattern of 1, 1, 2, 4, 3, 9 to the a equals 2 pattern of 1, 2, 2, 8, 3, 18. So let's actually go 1 over, 2 up, according to this first part of the pattern. So go 1 over, 2 up, and put a dot right there. And then we're going to go 2 over, 8 up. So from the vertex, it's always back from the vertex, 2 over, 1, 2, 3, 4, 5, 6, 7, 8 up, and put a dot right there. And of course, the last one, 318, that's pointless because if you go 3 over and 18 up, you're going to be way off the graph, so I'm not even going to bother with that one. All I'm going to do now is get this point and map it over to the other side of the axis of symmetry, and also get this point and map it over 2 units over to the other side of the axis of symmetry. And last but not least, I'm going to draw my parabola right through it. So I hope this helps because you could still use a pattern. Obviously, you want your a value to be 1. That's easy. 1, 1, 2, 4, 3, 9 is the easiest. But if it's 2, or if it's 3, or if it's half, all you got to do is modify it. Let's look at this next one. Actually, no. Let's see. Let's go with this one right here, number 4. It's a little easier. It says y equals 1/2 x squared. Okay, so we know that the vertex is what? According to H and K. The vertex is what? Anybody? 0, 0, because there is no H, there is no K. So now what we're going to do is use the pattern, but notice that the a value is 1/2. Now we know that the a value of 1 gives you the pattern 1, 1, 2, 4, 3, 9, if the a value was 1. But because the a value is half, the a value being 1/2, that's going to modify your second numbers on your pattern. So it'd be like multiplying by half, and by half. Okay? So what would my new second number be on the pattern? What's 1 times half? That's half. What's 4 times half? That's 2. What's 9 times half? That's 4.5 or 4.5, whatever you want to think of it. Does that make sense? So my new pattern, instead of 1, 1, it's 1, 1/2. Instead of 2, 4, it's 2, 2. Instead of 3, 9, it's 3, 4.5. So let's actually go to the vertex. And in this case, the vertex is 0, 0. So put a dot at 0, 0, the origin right there. And then from that point, I'm going to go 1, 1/2. So 1 on the x, let me zoom in so you can see this. 1, 1/2, that's going to be 1 on the x and then halfway up. So you're going to put a dot right here. The next one is 2, 2. So if you go to here, that'll be, if you go to here, that'll be your next point. And the next one is 3, 4.5. So I would be right here, map it over to the other side, and you'll have your parabola. I ran out of time, I apologize.